Okay, so now that we've got our electronics cabinet bolted in, our motor all hooked up, we know our motor's running. I didn't see any blue smoke, so I know my wirings should be good. Now I need to work on my control panel, and I milled that out on my CNC mill earlier. And so let's take a look at that. This is the front panel for my G0602 CNC lathe project. This particular front panel is one where I have manual potentiometer control for the speed, and I've also added a off button and changed out the forward and reverse button. So I now have forward and reverse, off, on, and EStop. And then this is for the potentiometer right here. I know it's a little blurry. So here is the G code for that. And I've got the workpiece located. And I actually kind of started before I realized I wasn't filming, so I wanted to make sure I got this on film. I'm going to be using a 2-flute. Going to be using a 2-flute 3/16 inch end mill to cut out the holes for the potentiometer and the buttons, and then we'll be engraving everything with a Tormac engraving tool. This is a 90-degree diamond tipped head. So let's get started. I'll put in our the faceplate around, and you can't really see the engraving that well, but hopefully when I get it finished you will. We've got the G code in Mach 3, and you can see I've kind of flipped I've rotated it so I can do the other half. Let's go ahead and we'll get started. Got our finished front panel. This panel is going to be for stage 1 with manual control, and I'll have a tach, my forward reverse, master on, master off, and my emergency stop. So I've got all of it wired in. I had to order an extra set of contacts for my EStop because I'm going to have one loop for Mach 3 and one loop for the VFD. That way when I hit the EStop, I can make sure everything gets killed at one time. Pretty much all of these contacts are the same, and I picked all these buttons up. This is the original button from the G0602. You can use the original forward and reverse selector, but as you can see, the wiring and the switch is a lot bigger and takes up a lot more space. So I just decided to go with this. This is the same type setup that's in the G0752, and basically it's the same button layout as the G0752. I just kind of emulated that. But eventually I'm going to have full CNC control, so I'll be getting rid of this and getting rid of the forward and reverse. I'll just have the master on, master off, and then my EStop button. So now I just need to run the control cables up here and we can get this mounted up. Forward and reverse, our off button, our on button, and our EStop line. So we'll get our cables run and then we'll wire this up. Okay, so the next thing I'm going to do before I connect all our wires to our control panel, as you can see, I've pulled the wiring through and tucked it all in real nice, and also closed up the back. And then now I need to put a proximity switch for our tachometer. Now if you look at these two proximity switches, you'll notice there's a difference. And the difference is this one right here is looking for a magnet. And this one right here is looking for steel. I ordered two of these. They came with the tachometer display, and I wasn't sure. They didn't specify whether this was a magnetic proc switch or a regular proc switch. So ordered two different types. The best way to identify these is the one that has the built-in magnet and is just looking for steel. It usually has this thicker plastic head rather than the one right here. This one is actually looking for a magnetic to pull the contacts and close them, and this one, it already has it in there. It's just looking for steel, and once it gets in close proximity to steel, then it will close the contacts. So because our spindle is solid steel, this one's more difficult to use. However, you can use it, and what I wanted to do was take and put a hose clamp around the spindle, and then every time it passed over it, it would be close enough to make the proximity switch, and then when it passed, it would be far enough away to open it back up. But this is fairly heavy, and I was afraid that it might throw the spindle out of balance some. So I'm going to go with the one that requires a magnet, and what I've got is just these super magnets, and what I'm actually going to do is just tape this to the spindle and run some electrical tape around, and I think that's going to be plenty to hold it. I've seen people put like JB Weld or some kind of epoxy, but I'm just going to put some electrical tape around it. Now you can see this one sticks to this because it's a magnet, where this one doesn't. just wants to fall off. So what I've done is made a bracket, and I just took a piece of aluminum sheet metal. I drilled a hole in it, and my lathe has this bar across here. It's part of the casting, but it's about 3/16 inch thick, and it's just flat. So what I did was I just took a piece of sheet metal and bent it around, bored a hole through it, and drilled and tapped a hole here. This is M4 by 75. Again, I'm staying everything. I'm trying to keep metric just because everything else is already metric. I don't want to have to be searching for different standards of wrenches. So, but it'll just go in like so. I'm not sure if you can see that, but it'll just go in like so, and then our proximity switch will sit in there like so, and it'll be close to the spindle. So what I'm going to do now is I'm going to go ahead and get the magnet taped on there, and then we'll get this mounted, and I'll see if I can get you a close-up picture of how it's mounted in there. Okay, so we've got our proximity switch installed for our Tach, and now I've got my wire coming from my electronics enclosure going up to my Tach display. This is the plug from the Tach display. Basically got yellow is my signal, red is positive 12 volts, and green is negative 12 volts. And I'm just going to solder these connections up real quick. And just follow the wiring diagram that comes with your particular proximity switch. I tried to keep the wires the same colors, but only the red one lined up, really, so. Alright, so I've got these connected, and I'll just put a little electrical tape around these just to keep them all tidied up. And then we can plug in our display, and that'll be hooked up. Just tape these up like so. Put heat shrink around them if you want. I don't have any more of the small heat shrink. I'm just going to use tape. I'm sure it'll be fine. Okay, so we have that tied into our proximity switch, and then it will plug into the back of our tachometer right here. Just plugs right in. We'll leave it unplugged until we get the rest of the stuff wired up. But we can move this over to the side, and we can work on the next item. And we will work on our on and off. Let's do our on and off switches next. That's our other 4-pin wiring. Okay, so now it's time to wire up all of our buttons. And the first thing I want to do is I want to wire up our jumpers. So we have power coming from 44, and it's going to be going to our on switch as well as our off switch. So we need a jumper between our on and off switches. So our jumper for our on and off switch is right here, this jumper. Hopefully you can see it. It's this jumper right here going between on and off. Our next jumpers is our power to our VFD for all of our forward, reverse, and our potentiometer. So we have 24 volts going to our forward, reverse, our EStop, one set of contacts on our EStop, and then we're going to jump that same power over to our on-off switch on our potentiometer. So we need a jumper between forward, reverse, the EStop, and then to our on-off switch for our potentiometer. So here I have forward, reverse, our EStop set of contacts, and over to our potentiometer. So now that I have all those in place, okay, so the first wire we want to connect after our jumpers is this red wire coming from KM1 contactor off contacts 44. That's going to supply power to our on switch, so it gets connected over here where our jumper is. So here is our on switch. And let me loosen this jumper up. And our red wire gets connected there. Okay. And then on the other side of our on switch is a blue wire that goes to the other side of the contact, 43 and 44, to the motor contact. That's a blue wire. Also to the on switch. Our next wire is our white wire that goes to the off button. We have our white wire. It's going to go to our off button right here. Okay, so that's our on and off switch wired up. This ground wire, it's going to just get screwed in with our when we screw our faceplate on. So the next thing to do is start wiring up our VFD, and we'll just continue on. Our first is our power over to our forward switch to the jumper side, and that is the red wire. So we have our 8-wire harness here. We're going to take the red wire, we're going to go over to our forward reverse switch. We're going to wire it into where the jumpers are. Right here. Doesn't matter if you put it on the forward or the reverse, as long as you put it on the jumpered side. Okay, so we have our power ran to the forward reverse switch. Then next is our forward wire that goes to our forward switch. It's black. So we bring our black wire over to our forward switch on the bottom here. Okay, then we have our reverse, which is our brown wire. And it goes on the bottom of the reverse. Okay. Next we have our base block. Now base block, the definition of that is an instant stop. And so I've got that wired up to our EStop. That's just a for safety. If I need to hit the EStop and kill my electronics, if I have to hit an E-stop and stop the spindle, I want it to stop as fast as I can, and that's what this base block is supposed to do. So we're going to wire this orange wire up to our E-stop, and we're going to wire it to the side, the opposite side of the jumper. Okay, we've got that wired up. So the next 4 wires, the E-stop, the 10 volts, the analog input, and the common, they're all going to get soldered to the potentiometer. So let me get set up to do that, and we'll get that done. So I've got all the connections made to the potentiometer. I have our blue wire that goes to our E-stop, which is actually our on-off switch on our potentiometer right here. And then I've got my purple wire going to the bringing power over to the potentiometer, our signal wire, which is our blue wire, and our ground, which is our green wire. So we have those connected to the potentiometer right here. Hopefully you can see that. If you're not sure which wires to connect, the signal wire, the 0 to 10 volt wire, should be in the middle, and then with the switch all the way down and off, you should have continuity between ground and this wire, the center wire, at all time. And this one is bringing power in. So that's how you can tell the difference. Just do a continuity check. Alright, so all we have to do now is plug in our tach and connect our E-stop line to, that is our other side of our E-stop loop. So now I have an E-stop for our control side and an E-stop for our spindle side. And that's just so that I can make sure that when I hit an E-stop, everything's going to stop. CNC motion will stop, as well as the spindle. Okay, so we've got all that connected. Got our, plug our tachometer in, and now we just need to tuck these wires in and get these grounds hooked up. So let me get all that tucked in, and we'll get it bolted up, and we should be good. Hey guys, well, you can see we've got our cabinet mounted, and so after we get it mounted, the first thing we're going to do, of course, is power it up and double check our connections, triple check, make sure everything looks good, and then we're going to apply power. And to do so, we just push the master on, the control panel. We've got power to the tach. Our fan is running. I can see my red light on my C10 board. I can see a green light on my 5-volt power supply, my tri-power, 5, 12, and 24 volts. And there's a light down inside on my 36-volt power supply. I've got green lights on my stepper motor drivers. And of course I've got some flashing numbers on my VFD. The contactor, you'll hear it click and pull in. And I just want to take a meter and verify my 5, 12, and 24 volts, verify my 36 volts, and there's a potentiometer on the power supply where you can tweak it a little bit if you need to. But for what we're doing, I think mine are close enough. The 12 is dead on, the 24 is a little under, it's 23.8, and the 5 volts is 5.01, so good enough. The next thing we want to do is there's a test procedure for your VFD to verify that it is going in forward and reverse. It's in your quick start guide here, and it says double check your connections, and then you want to press the run key and it should display 5.0 Hertz, and then you want to press the run key and verify that it's going in forward, and I did this already, and it's fine. It also tells you to put in 50 or 60 Hertz and press run and see if it runs at full speed. I've done all that, and now it's just a matter of making all our parameter changes. I made a list of the parameters that needed to be changed, and I'll post them in the video. For me, the first parameter that we need to change is 4, and that's your run command source. Do we want it to be the keypad or an external terminal? And ours is going to be an external terminal. The default is, of course, the keypad. So we've set that to 1, and to do so you just go into display function. You'll get your function number. You arrow up to 4. You press data, enter, and you can see we've set ours to 1. If you need to set it, you can arrow up or arrow down, and then once you get the right setting, you just push data in again, and then you'll pop back up to the F. Our next one is F5. F5 is our frequency command source. Where is it getting the command frequency to run? Ours is going to be from AIN signal on TM2, which is the TM2 is the terminal board here, and we're getting from an external potentiometer from the AIN analog input. So we're going to set that to 2. Our next one is F6. F6 is your external control operation. The default is 0, and we're going to leave it at 0, which is forward stop, reverse stop. And in the manual that you get on the disc, it gives you an explanation of that and how the switches are wired. But basically you have a forward and reverse normally open switch, and then you select which direction you want to go, and that is the default setting. The next parameter is F11. That is our forward, reverse, and default is forward, so we're going to leave it. F12 default is reverse. This is your multifunction terminals. This is S1 and S2. Forward and reverse is default. The only one I needed to change was S3, and I've got mine set up to base block, and I'm trying that out. I may change it to EStop. And so base block is just 7, so I changed it from 5 to 7. Excuse me, that was F12. I needed to be on 13. Changed it to 7. And that's pretty much it. It's all the settings you need for the VFD. Hit display function to get back into that screen. And when you switch from forward to reverse, it changes from 000 to SPO. And it gives you a description in the back of the text. SPO is 0 speed stop. If I switch it to reverse, it also gives me SPO. But if I put my selector switch in the middle and I'm no longer in forward or reverse, then I get just all zeros. Of course, the lathe won't turn when it's not selected either forward or reverse, because it doesn't know which way to go. So now that we have everything powered up, it's just a matter of turning it on. So we just select forward and turn our potentiometer on. And I'm on the middle setting, the medium setting. Full speed is 1280, which is pretty close to the 1300 that we figured. And notice that it's at 60 hertz, and that's the highest that the VFD will go is 60 hertz. And on the medium setting, it'll go down to about 140. $160, and it's nice and steady. I haven't even broken in the spindle yet. If you recall, we started tearing down the G0602 pretty much right after I got it. I never did even, I think I turned it on once just to see, make sure that everything ran. And that was still while it was on the crate. I just kind of plugged it in and turned it on. Now, I'm at 516 RPMs. I hit an EStop, and it stops pretty much instantly. Now, this is our base block function, and it'll flash BB on the VFD. But what I'm concerned about with this base block function is, once I remove the EStop, you can see the lathe turns right back on as long as we've left it in forward and we've got the potentiometer on. So I'm a little concerned about that. A little concerned about that. So I may switch those wires or change those parameters to EStop and do some testing to see how well that stops. If you noticed, it took a minute for it to get down to 0. But other than that, I think it's going to work just fine. This is our potentiometer control, and we'll probably run it like this for a little while, and then we'll do a full CNC, and I'll replace this faceplate and get rid of this potentiometer, get rid of the forward reverse selector switch. As you can see, we can move it to reverse. And it goes in reverse. Same speed as forward. And that's good. And then we're still powered up. Even if we hit an EStop, everything's still powered up. But we've got base block on our VFD, and we've killed everything. I didn't want to keep pulling in and out the motor contactor. It's just too much wear and tear on it. And all the electronics, it's not good for the electronics to be powered on, powered off, powered on, powered off constantly. So I've got it set so that if you hit an EStop, it just basically kills motion, but it doesn't kill the power. The fan runs all the time. for my door here, I took a screw and ran it into the box, and then I just taped right here. I just taped one of those super magnets right there, and that keeps my box closed. You see our cabling in the back, fairly nice and neat. Everything goes up. They're all go into the box here, and it gives it a nice clean look. Okay, so we've got our control panel for the top section, but I didn't do the bottom section. Now, originally I had planned on just removing these, but it appears that there's a stud sticking out, and so even if I remove them, there's still going to be this stud sticking out. So I figured, well, I'll just leave them and just make a plate for it. So let's take a look and see what we came up with. So this is the plate I came up with. It's just pretty much the same as the original. I just changed the graphics a little bit. The 1, 2, and 3 in ABC is really not needed because those gears aren't going to be used, but just to have something on the plate, I went ahead and put them on there. Okay, so let's see if we can get this milled out. Got my plate clamped in here, screwed down to a piece of plywood again, and everything's centered. So let's get started. Going to be using a 3/16 2 flute end mill, and we're going to be going 4 inches per minute at 2,000 RPM. So you can see that's the finished bottom panel. Not sure I'm going to do anything else to it. I may put the serial number down here that came with the original one. We'll see. Pretty satisfied with the way it's turning out so far. Thanks for watching the videos. Stay tuned. In the next video, we're going to start working on our mounts for our stepper motors and ball screws. Thanks for watching.